Section 4.1 is using graphs to relate two quantities. I can represent mathematical relationships using graphs. Big ideas. Graphs can be used to visually represent the relationship between two variable quantities as they each change. Tables and graphs can both show relationships between variables. In example 1, it wants us to analyze a graph. We're going to look at the graph on the bottom of page 234, which I have here. The graph shows the volume of the air in a balloon as we blow it up until it pops. What are our variables, and describe how the variables are related at various points in the graph. So our variables here are time and volume. Keep in mind, time just keeps going. So as time increases, it goes along steadily. So from 0 seconds all the way to however far we're going. As time increases, which means as we move from left to right, we read a graph just like we do a book. Our volume, it goes up steadily. And that's because we're blowing into the balloon. And then if we look, it flattens out. Where it flattens out, that's where we pause to take a breath. So volume, we say, remains constant. Because we take a breath. And then the same thing happens. The volume goes up steadily because we're blowing into the balloon. And then it remains constant because we take a breath. And then it goes up steadily, and then it remains constant. And then it goes up steadily until all of a sudden, so that pattern here is going to repeat. Until all of a sudden our volume goes back to 0. Until volume goes back to 0 suddenly. And that happens when the balloon pops. So it wants us to analyze the graph here, describe how the variables are related. So as time increases, our volume goes up steadily when we're blowing into the balloon. Then it remains constant when we take a breath. The pattern continues, so it goes up steadily as we blow into it, stays the same as we breathe, goes up steadily as we breathe into it, stays the same as we take a breath, until we're blowing into the balloon and it pops. So the volume goes back to 0 suddenly. Now we're going to look at the graphs on the top of page 235, which I have here. What are the variables in each graph? And then describe how the variables are related at various points in the graph. So in A, we're talking about the board length. Our variables are time and length. And they're changing here. So again, time keeps going, steadily increasing. So as time increases, our board length is constant. Until all of a sudden it drops straight down. So sharp, clean drop off. And that happens when we make a cut into the board. So we use a saw or something, and all of a sudden that piece finally comes off. Now our board is suddenly shorter. So that happens when we cut the board. And then it happens again. Same length, it's constant, and then a sharp, clean drop off, a cut. Then it's the same until a sharp, clean drop off, and then it's the same. So it repeats until eventually it remains constant. The length remains constant. And that happens when we get the board the length we want it. So here, it's a pattern as well. So as time goes on, we have a board of constant length, and then all of a sudden, there's a sharp, clean drop-off. So we cut the board. Then it goes on, sharp, clean drop-off. Goes on, sharp, clean drop-off. And then that length remains the same, and that's because the board is finally the length we want it. In B, our variables are minutes of calls and cost. So here, as our minutes of calls increase, our cost stays the same. It stays constant until then there is it's a steady decline. It goes up in a straight line. Steady incline, increase. And that happens, so what happens there is we start getting charged per minute. And this is a little bit outdated. So cost increases as minutes increase. I'm out of room there. So now most cell phone plans have unlimited minutes, but think about it for those of you that have ever been on a plan where your data wasn't unlimited, or maybe you still are. So you have a certain amount of data in your plan, and then when you go over your data, it starts costing a lot more, and your parents get mad, and they threaten to take away your phone or whatever happens because it starts to cost a lot of money. And so that's what's happening here. Same idea. It costs the same amount for a while, and then all of a sudden you get through the free stuff, the included stuff, and then it starts to cost more as you use more. Example 2 is matching a table and a graph. A band allowed fans to download its new video from its website. The table in the middle of page 235 shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? So if we look here, none of our graphs have numbers, so we have to look just at our patterns. So as my days increase, so from 1 to 2 to 3 to 4, so as I go left to right, left to right, left to right, left to right. I start off with 300, then I go up to 1,000, then I go up to 3,000, then I go up to 10,000. So these are going up and up and up, which means I start low and then get bigger. So it can't be D, because D starts high and then gets smaller. Now, if I look here, the change in between all of them First I go up by 700, then I go up by 2400, then I go up by 7000. So it's not the same every time. And we look, where's our biggest jump at? Well, our biggest jump here is only 700. And by here it's 7,000 more, which means we have a little jump, and then a little bigger jump, and then our biggest jump. Whereas in C, it's a big jump, and then just a little jump, and then a littler jump. So it can't be C, it has to be B. Now, the table on the top of page 236 shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. So if there's 0 uses, we have 5 ounces left, 1, 4.8, 2, 4.6, 3, 4.4. So if we look here, our number of uses goes up. We're going to check our relationship. In all of these, it starts high and then goes low. So any of these could work there. But if we look, our change here is minus 2, minus 0.2, minus 0.2. So our change is the same every time, which means it can't be B. And the difference between A and C is that in A, it tells us after 4 times it's 0, but here it tells us it's 4.4. So it can't be A, it has to be C. And I'll finish this section in another video.